Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. If you really like my teaching and my efforts, please press the like button, share the videos with your friends, subscribe to my channel, and also press the bell button to get the regular updates. In the last few videos, we have discussed about the NAND and NOR properties and whether it is satisfying the basic properties of the Boolean algebra or not, we have discussed. Now in this video, I want to check about the exclusive OR. Okay, exclusive OR, the gate or the function, what kind of output it produces, and also whether it satisfies the idempotency property, commutative property and associative property or not, we will verify. So I request everyone to watch the complete video for better understanding. Now we will take two binary variables, which is A and B. And now how to represent the exclusive OR? Exclusive OR can be represented as like this. Now whenever A and B is 0, 0, 0, 1, 1, 0, 1, 1, what is the exclusive OR will produce? The exclusive OR gate can be written as A's B complement or A's complement B. Am I right or wrong? So substitute the A value and B value as 0, 0. Then what it produces? 0 and 1, because B's complement will give the 1 and A's complement will give the 1 and B value is 0, which is equal to 0 and 1 is equal to 0, or with 0 finally you will get 0. So what I can say that when the A value and B value are equal, this exclusive OR will produce the output as 0. In another two cases, it produces the output as 1. If you want to verify, you can verify it. Substitute the A value and B value as 0 and 1. I am taking this case. Okay. Now, if A value is 0, it will be 0. B value is 1, so 1's complement is 0. So 0 and 0 you got. Or A's complement, meaning is that 0's complement will be 1. Already B value is 1, so 1 and 1. Now 0 and 0 is equal to 0, or 1 and 1 will give the 1. So 0 or 1 is equal to 1. So that's what I said. When A value and B value are different, it produces the output as 1. If they are equal, it produces the value as 0. Is it clear? Now we will discuss about the basic properties. What is the first property we will discuss? We will discuss about whether it is idempotency or not. Okay, how I can check? I will take the A exclusive OR A should be equal to A. Then I will say that exclusive OR is satisfying the idempotency property. Now substitute this one in the equation. What you will get? A exclusive OR A, which is equal to A and A complement, or A complement and A. Am I right or wrong? If I simplify this equation, this one I will get. Now we will see A and A's complement is equal to 0. Again, A's complement and A is equal to 0. If you want the proof, I can give with the truth table. You take the A value. A value can be 0 or 1. What will be the A's complement? If A value is 0, A's complement will be 1, and here it is 0. Are you able to understand it or not? Now perform the AND between them. What is AND? If both the inputs are 1, then only the AND function produces the output as 1, otherwise it is 0. If you see that here this input is 0, so it is produced the 0 and 0. So that's what I said. A and A's complement will always produce the output as 0. So 0 or 0 is equal to 0. So LHS I got 0. RHS side I have A. Whether 0 is equal to A? No, they are not equal. So I can say that the exclusive OR operation or the function does not satisfy the idempotency property. Okay. Now we will check whether it satisfies the commutative property or not. Okay. What is the commutative property? It says that A exclusive or B should be equal to B exclusive or A. Will you accept with me or not? Now we will check it. A exclusive or B can be written as A B complement or A's complement and B. Is it visible for you? If it is not visible, let me write it properly. It can be written as A B complement or A complement B, which is equal to, even if you take this one, simplify it, B A's complement or B's complement A. Am I right or wrong? Now tell me whether these two are equal or not. Here you have A B complement. Here also you have A B complement. Here also you have A complement B. Here also you have the A complement B. So you are adding both of them. Then obviously they are equal. Suppose if you have 5 here, here you have 2 is equal to 2 or 5 or not. Yes, both will produce the output as 7. So I can say that LHS is equal to RHS. If you still have any doubts, you can substitute the values and you can verify it. Or to make you understand with a truth table also, I can tell you. Now see, what is the B exclusive or A? Am I right? I want to check whether these two are equal or not. So what I will do, I will take the A values and B values 0, 0, 0, 1, 1, 0, 1, 1. I already computed the exclusive OR of A exclusive OR B. What is the output I got? 0, 1, 1, 0. Even this function also should produce the 0, 1, 1, 0. Then I can say that these two functions are equal. Let's see what I said about when I was discussing about the exclusive OR. If both the inputs are same, then it produces the output as 0. So here B value is 0, A value is 0. Even it produces the output as 0. Here also B value is 1 and A value is 1. Even this also produces the output as 1. Whenever both the inputs are not equal, exclusive OR produces the output as 1. So if you see that both the functions are equal because they are producing the same output. Is it clear? 0, 1, 1, 0. Even it is producing 0, 1, 1, 0. So I can say that these two functions are equal. So I can say that, or I can prove that the exclusive OR is satisfying the commutative property. Now we will see the associative. Okay. What is associative meaning is that A exclusive OR B exclusive OR C should be equal to A exclusive OR B whole exclusive OR C. Now whenever you have the more than two binary variables, what we can do is that one way is that we can find the truth table for this one, find the truth table for this one. If both are producing the same output, then I can say that LHS is equal to RHS. Otherwise, what we have done is that we have substituted some value. Let's take that I am substituting A value is equal to 0 and I simplified this equation. If I simplify this equation, what will happen is that I can reduce this equation into two binary variables. Then I can verify whether LHS is equal to RHS or not. So now I will substitute A value is equal to 0 in the LHS and RHS. Let's see what I will get. I will get it as 0 exclusive OR B exclusive OR C should be equal to 0 exclusive OR B exclusive OR C. Am I right? Now if you see that 0 exclusive OR anything, what will happen? 0 exclusive OR anything, what you will get? Anything you can say? We cannot say anything. Let's see it. Let's simplify this equation. How I can simplify? Okay, 0, okay, and B exclusive OR C whole complement. plus, okay, zero's complement and, okay, B exclusive or C. Am I right or wrong? See, what is this expression? I can write it as A exclusive or B can be written as A and B's complement, or A's complement and B. That is what I have written here. So in this case, 0 is A and this whole part is B. Am I right or wrong? So that's why A, this B's complement, or A's complement and this B. Now if you see the thing, 0 and anything, you will get what? 0 only. Will you accept with me or not? Or have you understand it or not? Now if you take this 0's complement, which is equal to 1, 1 with and with, not and with this one, what you will get? The same B exclusive or C. Is it clear? Are you able to understand? Now come to the, even we will simplify this equation. 0 or with this one, this is equal to B exclusive or C. So I can write this equation as left hand side as B exclusive or C I got. Okay, I got the left hand side equation as B exclusive or C. Now we will see what we will get in the right hand side. First you perform 0 exclusive or B. 0 exclusive or B is nothing but 0 B complement or 0's complement B, which is equal to B only. Will you accept with me or not? Because 0 and B's complement is equal to 0. 0's complement will be 1. 1 and B is equal to 0 or B is equal to B. So I got this side also B and I have the exclusive or C. So if you see that LHS I got B's exclusive or C, right hand side also I got the B exclusive or C. So I can say that LHS is equal to RHS. So exclusive or is satisfying the associative property. I hope you have understood how I solve this one. If you still have any doubts related to this concept, feel free to ask your doubts in the comment section. I will try to clear your doubts in less than 24 hours. Thank you for watching my video. Have a nice day.